Now in whole decision tree chapter, the most interesting as well as most challenging part is the to draw the decision tree. So actually we have a data set D, and at that time we have divided the data in two partitions. One is D train data and another one is D test data. We have already seen this concept, and the most challenging part is here from the D train data to build D to build the decision tree. This is the most challenging and as well it is a interesting part. Okay, now to build a decision tree, we need to know one concept, that is the entropy concept. So let's actually, what is entropy? What is actually entropy? Entropy itself a subject in information theory. I think if you are coming from electronics background, then you are already known about the entropy. So it is an a concept from, it is coming from information theory subject. Coming from information theory concept, and mostly these concepts are used in physics as well as mathematics, computer science as well. This concept is used. Now let's see what is actually geometrically meaning of entropy. Let's see it first. So suppose let's take I am taking this example to understand this entropy concept betterly. Okay, suppose let go to the theory part, then I am coming to the example. Suppose let we have considered a random variable. Suppose let we are consider a random variable y. Let and it's y, it takes the value, and in this y it takes this value. Suppose let's take, it takes the value y1, y2, y3 up to yk. Let this random variable y takes this value, and the entropy, the definitions of the entropy of this random variable will be, the entropy of this random variable definition will be what? Minus of summation I is equals to 1 to how much value it has taken? It has taken two values. Sorry, it has taken k values. So the summations will be I from 1 to k, probability of the value yi into log of b, probability of yi. The question is, what is actually b? So where b will be simple, b will be 2, in general 2, or it will be Euler number e. It will be Euler number e, that is 2.718, something like that. This will be, and if we taken b is equals to, if we taken b is equals to 2, then this log base 2 in generally, if we taken b is equals to 2, this log is called generally log of 2, means in generally this is lg, written by lg. If we taken log e, log base e, then this log is in general taken lg of n. This is the simple concept of logarithm. So this h of x now is called the, this h of x is called the entropy of the random variable y. This h of x is called okay, and p of yi means what? It is nothing, p of yi it is simple similar or probability of the random variable y, its value will be yi. This thing means that this yi. This is the simple definitions of the information theory. In entropy, this is the simple definitions of the entropy. Now let's see what its actual geometrical meaning through this example. Now let's come to the, suppose let's, if you just call this variable, if you just call this play as a random variable y, then this play random variables is will take two values. Actually it is a categorical feature, categorical set, and it's take two values. It will be yes or no. It will be yes or no. And for each of us, we have calling yes as y plus, and no, I am calling it as y minus. Okay, this is simple. I am taking this random variable play as y. I'm taking this. Now let's see how much yes we have. How much yes? 1 2 3 4 5 6 7 8 9. So total we have 14 data sets, and out of 14 we have how much data? Yes, we have 9. And how much we have? 9. No rest of that, means 14 minus 9 is 5. So now what will be the probability? Now what will be the probability of y plus? So what will be the probability of y plus? It will be, we have number of positive points 9 out of 14. What will be the probability of y minus? Means it will be 5 by 14. Okay, so or simply you can easily calculate this formula, probability of 1 minus y plus, because actually in this random variable we have only two values. In this random variables we have only two values, so you can easily find it by this formula. Okay. And now let's call this is our data set, whole data set. This is called as D. This is the D data set, whole data set. Now what will be the entropy for this random variable play? Now let's calculate the entropy value for this random variable y. Let's calculate. So the what I'm seeing the formula, just look up. So here k is equals to what? Here k is equals to, here k is equals to 2. K is equals to 2. So this formula will be now minus probability of y plus, minus probability of y plus into log I'm just taking log to the base 2 here, just for example I am taking here log to base 2, but it is depend on situations. You can, if you interested, you can take log to the base e, but let's take, I am taking here log to the base 2. So probability of y plus minus similarly probability of y minus log to the base 2 probability of. Now let's calculate it from here. For this data set, let's calculate it. So what will be probability of y plus? It will be 9 by 14 log of 9 by 14 minus 5 by 14 log of 5 by 14. Okay. So after calculating, just if you use the calculator, then you can easily find this value, 0.94. So means what? Actually means what this value? What are these values telling about? So first see this thing. First understand this thing first. What is meaning about minus 9 by 40 minus 9 by 14? What is actually meaning about this value? This value means number of positive points, number of positive points divided by number of total points. This 9 by 40 means, and what it actually means, this means that percentage of positive points in our whole data set T, in the whole data set T, percentage of positive points in the whole data set T. Similarly, for this value also, this value means that percentage of negative points in the whole data set, this value, and after that we have calculated this value. Now let's see actually what is means. First see the property first. I think they don't really be good. First property, let's see the property. Let's see the property first. Okay, so our here random variable y took, so how much value took it? Two values, y plus or y minus. Y plus or y minus means here we have only two classes, or simply we can call it is a two category we have. We have two category. So let's discuss this case one by one. Okay, let's discuss it case one first. Case one. So let's case one from our let suppose let consider from our data set D. This is from our data set D, our y plus our data set D, our y plus value, and this is our y minus value for the random variable y. So suppose let's take our y plus will occur 99%, and only 1% occur the negative value. So let's take this example. Let's see for case one, if this value occur, then what will be the entropy value? Let's calculate. Now this entropy value will be, first means minus, this value will be 90% and this value will be now 1%. This, if this is 90%, means minus 0.999, sorry, 99%. So this value will be minus 0.99 log is 2, 0.99 minus 1%, 0.01 into log of 0.1. So if you calculated this value will be approximately equals to 0.0801. Just calculate using the calculator, you can easily find. Now let's take case 2. Now let's take case 2. Let's take, in this case we have the same number of points. Y plus and y minus are the same number of points, means y plus is 50% at, as well as y minus is also 50%. Let's take, now let's calculate it. What will be the entropy value here? So here entropy value will be minus 50%, 0.5 log of minus 0.5, similarly minus 0.5 log of minus 0.5. So if you just calculate it, then you can easily get this value as well. Just calculate it by using calculator, then you can. Now let's consider the third case. Case 3. Let's take here from our data set, here y positive value, the occurrence of the positive value is 0%, and the occurrence of the positive value is 0%, and the occurrence of the negative value is 100%. Let's take in such situations what will be the entropy value. First calculate the value, then we will compare it side by side. So this value will be minus 0%, mean minus 0 into log of 0 minus 1 into log of 1. So both the cases 0 into multiplied by 0 is equals to 0, and 1 into multiplied by 0, both the cases it will be 0. Now you will see this thing. Now what is actually occur here? What is actually happening here? Just see this thing. Just see this thing. When just first see the case 2, when the number of occurrence of the both classes is equally probable, then our entropy is actually 1. If but see the now see the case 1. Here in these cases we have more preferences occurrence of the y plus. Just I will give the more preference for one classes, and another classes we get the paper neglected these classes. So in such cases we have seen that our entropy value is tends to 0, such less value. Okay, and if you just totally ignore one classes, and if you prefer another classes, here actually I have ignored the y plus classes, and I have mostly preferred the y minus classes. So in such cases our entropy value is actually 0 value, actually 0. This is the thing. Just see this thing case wise, case 1, case 2, case 3. Just pause this video and think yourself what is actually happening and how this thing is interpretable to geometrically. Just think, if our two classes, occurrence of the two classes are equal probable, then in such cases our entropy value is high, is 1. If we dominate one class to another class, then our entropy value is reduced. Okay, so for the same cases, both will happen both will happen. If one class is dominated by other classes, then this entropy value will be tends to 0. So now let's see this thing. Now just if you just draw this pictorially, suppose let's take its value is our probability of y plus, and this value is entropy value h of y, entropy value of the y. So if you just draw this, so this picture will be probability maximum, minimum value is, the minimum probability value is 0 and maximum is 1. Similarly, the minimum entropy value is 0 and maximum value will be 1. So just if you just draw this picture, then you will see when we dominate one classes, it will be increased, after that it will be decreased. So here it will take, suppose let here is a 0.5, here it will take the maximum value. It will take the maximum value in this point. It will take the maximum value. So what we will conclude it here? What we will conclude it? We can conclude it that here we can conclude it for both the cases. If we take y plus as well as if you take it y minus, both the cases the graph will be same kind, similar kind of graph. We will see. We have seen this kind of graph for both the cases. So we will see that if we have two classes, just this case is this plot is only for two classes. Just I am taking here only y plus and y minus. If you increase the class level, so this plot will be changed totally. Just in this example, I am taking the two classes only. So in such scenario, what happen? If we consider the only two classes, that is here I'm taking y plus or y minus, then what says what is actually happening, we will see that first for equiprobable equal probable for equal probable classes our h of y value will be maximum. And the number two case is that if we dominate one class through another, if we totally dominate one class, so in this case what happens, our entropy value of this random variable will be minimum, means 0, means 1, maximum means 1. So this thing will actually happen. Suppose now let's take our random variable takes the discrete random variable. First take the consider the or y is a random variable, and it's here I am taking the two values, only two values for this random variable y. Now let's take for a random variable y we have k values, y1 y2 up to yk. Let's take, so in these cases, if these are the equal probable, for if these h classes, here h classes is equal probable, means what, if this is our h classes is equiprobable, then what happen, then our entropy will be maximum, okay. This thing happens. Suppose let's see this thing pictorially. Let's see this. Suppose it is our random variable y, and it is the, suppose let's take it pdf, probability, we have just interest to drawing the probability density function, let's take, and it's the value, the random variable, it's the value of the random variable, y1 y2 y3 y4, let's take is the value yk. Now if both the classes are equal probable, so what will be look like the probability density functions, here this kind of probability density functions we will see both the classes occurrence. So in such cases means it is parallel type of, in this it is the parallel type of, so we will get this kind of access we will get for discrete cases only, for discrete cases, okay. So in such cases our entropy will be maximum, for such cases our entropy will be maximum. But if we just take, if we give the more preferences for one classes, suppose let's take we are give the more preferences one classes and we have neglected the other class, means if you just to get the more preference for only y1, so its corresponding probability density function will be 1. We give more preferences here, it will be picked here, this graph will be picked here, we will give the more preferences for, and the rest of the for rest of this function it will take the value 0, this kind of, here it will take 0, here 0, here 0, here 0, only I am giving the more preferences for this. So in such cases entropy will be Entropy will be in such cases minimum. Okay. Okay, let's see this thing through we will see this thing in discrete cases only. We will see this thing only for discrete cases. Now let's visualize this thing for continuous cases, for continuous random. Let's see. So just one thing we can conclude here: more Picard is a distributions, less entropy. Less is in its entropy. So the more Picard, just first see this thing through a continuous case, then it will be more visualizable. So let's take continuous case. So suppose this is our random variable y, and this is the corresponding probability density function. Let's take. So here, suppose let's take our random variable y is lie between a and b. Random variable y is lie between a and b. And if all the classes are equal probable, if all the classes are equal probable, well, take another color. A, B. If all the points between A and B are equal probable, then the probability density functions picture will be look like this. Look like this. Okay. So in this means what? This means it is a uniform distribution. This means it maintains the uniform distribution. It maintains the uniform distribution. Okay. And in such scenario, what will happen? In such scenario, our entropy will be maximum. In such scenario, our entropy will reach maximum. And now let's consider the another case. Let's consider the another case. So it's the random variable y and its probability density function. Okay. And let's one random variable is here. Suppose I have taken pink color. Suppose let's take our one random variable is Gaussian distribution and spread it more in this region. Let's take its lies between a to b. And here in the regions of a and b, this random variable, let's y1, it's spread it like this. This random variable y1. Now let's consider another random variable. Suppose let's take this random variable also lies on this radium, but it is the more Picard like this in these regions. In this region, just see the blue color, blue ink. It is the more Picard. This random variable is y2. This is the y1 random variable. This is the y1. Means what is actually for y1 random variable, actually spread for this y1 variable is much than the spreading of the y2. Means in y2 variables, most of the points lie in these regions. Most of the points lie in these regions. Okay, but in y1 variable, just see the y1 variable, most of the point lie is in this region. In this region, most of the point are lie is in this region. Okay, so the spreading of the y1 variable much more than y2. Means y2 in the y2 random variables, we get less important. We give the less importance for all the values, but in y1 variable we give the more importance. Means its occurrences, chances of the occurrences for y1 variables is more than y2. So in such cases, what happen? In such cases, here y1 is less peaked, and here y2 is more very peaked. very picard, very picard. So in these cases, our h of entropy of entropy of y1, entropy of y2 will be less than entropy of y1. Okay, I think you have understand this thing. So because it is the least peak means it's the occurrences, chances of occurrences is more chances, or max it is the less picard, and it is the more picard means it's the number of we here actually we give the more importance for less number amount of points, we give the more importance. If you just conclude this thing here, we give we give more importance for less amount of point, for less will give the more for less amount of point. And in these cases we we give more importance means equally importance, more means it will be better language, you give equally importance for maximum number of points, maximum amount of points. Okay, equally it will be better language, more importance, not equally here, more maximum number. Because of these two regions its entropy it's high, because of these regions its entropy is low. Okay, so the conclusion is that more picard a distribution is less it is entropy. The conclusion is that more picked a distribution is means less is its entropy. Okay, I think the concept of geometrical concept, I'm not discuss about this how these equations come, how these things is. Actually, this is the this is the not our discussion topics. Actually, I just give you the flavor of the entropy. I just try to give the flavor how the actually entropy, how is actually meanings of this geometrical meaning. What is actually geometrical intuitions of the entropy. Now we will see this thing how these things actually applicable to build a decision tree. Okay.